All right, so part B, again, we are trying to determine if the graph represents a function or not. So here we have the graph of what in mathematics is called a parabola, and it's kind of this U-shaped graph. Now, I'm going to draw some vertical lines here. And notice I've gone ahead and I've drawn 4 vertical lines that cross our red parabola U-shaped graph. And everywhere that I've drawn those vertical lines, my vertical lines intersect the red graph at only one location. And hopefully you can see that I can draw infinitely many vertical lines, but the vertical lines are always going to intersect or cross the graph at only or exactly one location, unless I draw a vertical line off to the side here. You can't necessarily see it, but these red arrows indicate that the graph is going on forever, so it's going to cross the graph somewhere and only at one location. So off to the side, I would say this is a function. It passes the vertical line test. Now, because it is a function, the problem has asked us to state the domain and the range. So I'm going to go ahead and erase these vertical lines that I've drawn. And if you need a reminder, the domain is all of the possible input values. And the range is all of the output values. So if we were returning to the vending machine analogy, the domain would be like the buttons that you're able to push, and the range would be all of the snacks that could pop out. Now, usually a lot of times people will frame it so that the domain represents the x values. Now, this is our x-axis, and so notice that we can plug in any x value. So give me an x value. Let's say I wanted my x value to be 2. So here is the x value of 2, and notice that if I plugged in 2, then here my output would be 2 as well. So let's say f of x, this graph let's call it f of x. So that means that f of 2, if I evaluated the function at 2, the output would be 2. And let's see, if I plugged in 0, so here's 0, my x value of 0. If I plugged in 0, notice that the graph, the red part is right there. So we would say f of 0 equals -2. And notice that you could really do that for any x value. And because these arrows are here, they're going forever in both directions. So really, our x values could be anything. We could plug in anything into this function. So the way that we denote that in mathematics, using what we call interval notation, I'm going to put a parentheses, -infinity, comma, +infinity, and hopefully you've seen in a previous video that this means that we are looking at all numbers between -infinity and +infinity. So another way of writing that is we could say all real numbers, but oftentimes we'll write it in interval notation. So let me just indicate here that this is called interval notation. Okay, and now let's think about our range. Our range does not work the same way here because we're looking at the y-axis. Let me highlight that again. So the y-axis is right there. And notice that the lowest point on our graph is when y equals -2 right here. Notice that it's going upwards from -2 and it will never go below this highlighted line. So our range is not everything in this specific example. What that means is I'm going to put a bracket to indicate like the lowest y value is -2. But notice that it does go upwards forever, so it goes off until infinity. So basically, our range or our y values or our output values, they start at -2 and go upwards from there. So our range is going to be everything between -2 and infinity. We have another graph here in part C, and it's kind of split up into two components, but still, if I draw several vertical lines, it's only going to cross our graph at one location. Now, the only area that might be in question is what we see on the y-axis. So if I drew a vertical line right on the y-axis, we might ask ourselves, is that hitting the graph at two different locations? And the answer is no, because there is a solid dot at the origin, but at the point 0, 2, there is an open dot, which means that the function is not existing on the open dot, but only where the closed dot is. So because every vertical line crosses the graph at only one location, that means that this is a function and it passes the vertical line test. So this is a function. It passes the vertical line test. Okay, so now because it is a function, we want to discuss the domain and the range. Now, notice that this graph, this purple graph, doesn't have arrows attached to it. And in fact, it has on the ends, it has these open circles, which indicate that the graph does not go on forever. So our domain and range are going to look a little bit different in this scenario. So notice that the leftmost point is right here when x equals -3, and then it goes and it stops at the rightmost point when x equals +2. And one thing that we have to notice is that both of our endpoints are open circles, so that means that -3 and +2 are not included in our domain, so we have to use parentheses to indicate that. So the leftmost point is -3, and then the rightmost point is +2. And I'm enclosing those x values with parentheses instead of brackets. Okay. So now let's talk about the range. So if we're thinking about this vertically, so our bottommost point is occurring right here at the origin, and then the highest point is happening right here when y equals 5. So remember that when you're writing interval notation, the smaller number always goes on the left of the comma, and then the larger number goes on the right. So the smaller number that we're dealing with is 0, and the larger number that we are dealing with is 5. And because there is a closed circle at the origin at the point 0, 0, we have to use a bracket because 0 is included in our range. But because there is an open circle when y equals 5, we need to include a parentheses. So let me just box our final answer there. That is our domain and range for this example.